So hello everyone. In the last video we just a quick recap to have a really super quick recap. Let's do the recaps as in it's a good revision for us. We have covered quite a good sum of topics. So let's do like functions. Well, we know what functions are. Um, so equivalence relation. So you have reflexive, symmetric, transitive, partial order. Um, we really have to revisit these later on. Histogram, and we really have to revisit these. I mean, um, Conger model and related, correlated, equivalence relation. Partial is an anti-symmetry relation when A is R to B and B related to R to A, then A equals B. So if A is related to B and B is related to R, then you have A equals B is related to B. Antisymmetry are both related to each other. They are the same object, but like the comparison operators. Comparison. So we have the partial order equivalence relation. Equivalence relation is when you have a reflexive and symmetric and transitive properties also found. So reflexive is when I are A, and then symmetric is when A is related to B and B is related to A. Then and transitive is when I A to B and B or C, then A is related to C. That's transitive. Uh, we have to do a video on this, like revisiting everything that we've studied, and we need to have a video for each of these topics and cover each. So if we've went through each and every topic to reach the matrix, and in the matrix, I mean, before hitting on the matrix, we read a little bit about, well, we've read a lot about the slopes, and we know what the equation of the slope is, mx plus b, and then b is the y-intercept, and you could have multiple solutions, or you could have infinitely many solutions for an equation given they share the same slope. um, we have all these goodness here, and then we try to solve equations. You have to solve systems either using substitution or elimination, and you can have consistent or inconsistent solutions, and this is basically what we have seen in the last video. um, Percentages, when with the percentages, when the denominator is large, it's usually less than 100. However, when it's larger than the denominator, that is more than 100%, actually 50%, while 3/4 is actually 150. Yeah, that's something good to remember. um, the numbers, as I said, numbers, I don't think we really have to revisit it much because we've been doing a lot of it. And sets is something quite interesting because, as you know, with sets, we have had our share of. We were acquainted with getting the number of elements, the order of a set, which is to the power of n, and then we have a what do you call it, a proper set, which is you have all the elements, excluding the number of elements, the subset of its own self. And then when we have to determine um, like Pascal's triangle, permutation ordered. So basically, this is when we have a set and then the number of elements in that set, and then we want to get the number of subsets choosing x elements, which is the k. Then we would have to opt for the factorial. And then there's the Pascal's triangle, in which we could make use of it. It makes things a lot easier, but we could skip that for now. Again, I think we will have to revisit all these, but yeah, and then we have the sets including and excluding, and then we also have these relationships where we have a cumulative, commutative, or associative property. Um, Associative property and commutative. And then there is the symmetric difference, which is the delta. Uh, okay, so we have the symmetric difference using a. May sound like it's the same as a subtraction, but it is not. It should be bolded because you know what it means. It's basically something similar to the XOR. So you have A minus B union. So the symmetric difference is um, union excluding the intersection. So everything minus, so A plus B minus A intersecting B. Yeah, A union B minus A intersecting B. So that's what the symmetric difference is all about. So you exclude whatever is the common properties, you exclude them from the list of properties, whatever it is, right? And then you have functions and mapping. Now we have dependent and independent variables, and then we also have x and y, and then we also have, so when y equates to, given a function of x, then y is the independent, the dependent, and x is the independent, which is you map that to that, right? The domain of f and the range, all the good stuff. Then in the equivalence relation, we have the esoteric, and oh my goodness, I believe, if I'm not mistaken. The slope, we've already done that. The parabola is x to the power 2. We have a lot of goodness in the slope. Solving the equations. Then I remember having the system being esoteric and not esoteric. It's sorry. It's when you have the type of relationships. Oh goodness, we have a lot to revisit, right? I'm starting to forget much of it. So that's the equation for the parabola. Yeah, the matrix. So in the matrix, the last we've stopped at the matrix. When we stopped the matrix, the last thing we've talked about was actually. So first of all, we need to have a plan forward. We have to have some sort of now what we need to do, just to give an idea on how this is going to be all done. We will create a visit video for each of these topics. So in total, we'll have 1, 2, 3, 4, 5, 6, 7, 8. We'll have another 8 videos, each video for a given topic to revisit, and then we need to do a couple of exercises on each one of them. And we will also be looking at doing like a proper video on how this is done. And we're actually thinking about open sourcing all of this information later on, but we'll see where that takes us first. But yeah, so each video, each subject or each topic is a video in its own. We need to revisit all of this and do exercises on each and every one of them. Now, given we've already briefed on what we have done so far, let's do a quick revisit on the matrix as well. So we have the matrices, and then we have the general operations that we talked about in the last video. We have the addition, subtraction, multiplication, and division. So division is just multiplying by the inverse of the function. We did not look into the multiplication yet. We will look into that in this video, or maybe the next. We could just have this a video, like a quick recap on whatever we're planning to do next. But generally speaking, on what we have done so far, the addition. So we've done the addition, and then we've done the subtraction, and we've done what's called the transposing. Now, something we should keep in mind is that adding matrices has to be they have to be of the same size, otherwise addition would not really be possible. And transposing is converting rows to columns and columns to rows. That's what transposing is about. And then we have all the other good information that we have. So instead of us, as we've seen when we were talking about the slopes, we talked about solving systems, right? And when we did solve these systems, we did what's called substitution and elimination. Now, if it's if it's an equation of two variables, it's generally easy to solve those using substitution or whatever. But going for matrix makes things a lot easier. So you plot in the coefficients in the matrix, and then you do this to do what's called the elementary row operations, or you do the Gaussian elimination, and then so that with the Gaussian elimination, you have a main diagonal leading ones, and whatever is at the bottom is all zeros. So there has to be a leading one in each of the rows. And then you could also opt for Jordan-Gauss elimination, where you have both whatever is below the diagonal, both ends. You try to set a leading one on each one of them, and only one on the row, and with the condition that there is only one in each column. The rest would be zeros. Anyway, so the system of linear equations, you'd have to have some sort of a plan to solve it all, right? But okay, so you just plot and then you do the general operations, swap, pivot, and multiply by a scalar. So multiplying by a scalar, we've seen too that, yeah? So when you have a scalar and you would multiply it by each and every element within the matrix. And when you do the multiplication, what happens to the graph is that you actually start to change the graph. So instead of this, so this is the leading one, so that's fine, we can leave it as it is. But then this one has to be a 0, right? So so this has to rotate around its own axis to become parallel to the x-axis. And yes, this is how it happened. Second row. And then if we look at this, so this is it being the second row is being parallel to the x-axis. Now if you try to do the same for the one below, and, you would want it to be parallel to both x and y. So it's parallel to both x and y. X and y is parallel to both. It's parallel to both. Right. So, right. Now with the Gaussian elimination, row echelon form, row echelon form, row echelon form. Okay. Now you have to keep in mind that there are just like we've seen with with using elimination or substitution, there could be many solutions, there could be none, or there could be infinitely many solutions. And the way to know that, you could actually do that using the reduced row echelon form. If you have, say for example, this being 1 and this being some other variable, then you really don't have a solution. It's inconsistent. And we have seen this like in this case here, -1 does not really equal negative. Oh, sorry, I was actually mistaken here. This is actually not the way you could actually think about it. It's like Z is equal. This is actually, there is a unique solution to the problem. But when you have that's actually a unique solution. But if you, for example, if you got, like in this case, this case is this has infinitely many solutions. But if you got a different constant here, then it won't be a release. It won't have any solution at all. And it's something we have seen. This could have many solutions. Gestation form. Now this has a unique solution. This is totally fine. Now this is where things get a little tricky. No, this is totally fine too. But I don't think I have an example here where you. Oh yeah, a 0 equals a negative 32. That doesn't really make any sense, and for that reason, this is an inconsistent solution, and for that reason, there are no solutions to this problem. Alright, so with that said, I will probably end this video here and start on the new one, which is a matrix multiplication. And this was like a really super quick recap on what we've done so far, but we still have to do a better recap on each of the topics that we've covered so far, especially on equivalence relation. It should be easy to recall, and in the slopes as well, we've covered a really good chunk of information on that front, on that one. And I guess, as time progresses, we will be able to, uh, swift through whatever is left of the topics. As far as I remember, the things that we still have to cover is that we still have to cover the matrix multiplication, which is in the next video. We will also need to cover the different operations involved, like the multi-division, which is basically part of the multiplication. And of course, there are different types of matrices that we really have to cover as well, which is, I can't really recall the names of those, but based on this series of videos that we have been going through as of late, there are still we still have a bit more of information to cover, and I think, if I'm not mistaken, um, let me try to bring up the series of videos. Like, if we take a look at, for example, this dude here, and we will be able to see, like, with ease, that, like, you see the playlists, then in algebra, we've basically really covered a lot of the topics that he has introduced, and we are way down below. It's like around 60 something. Yeah, it's around 60 something, 64. So the next topic we will be discussing here is quadratic functions, which we could converting between general and vertex form, solving different quadratic equations. So quadratic equations could be left for later. I don't know. As we see, if we see fit, we could revisit these later on. But for now, I think we just have to uh, stop here and then do the rest of the. So we still have to go for multiplying matrices, and then inversing a matrix, and then solving systems of linear. This is something using matrix. I think this is matrices. This is something we've been doing. But it would be interesting to look into um, the possibilities we have, the examples we have. So we've done the Gaussian elimination. I think this should be fall. This should fall here. Sorry. Anyways, we should. It's interesting. I'm not sure if this is 8 by 1 Let's do it again. Yeah, I think this should be the things we're looking for. If we try to look at, I'm not sure if it's the linear system, linear equations, matrices, system of linear equations. Okay, inverse multiplication, inverse. This is what I like about this site, is that it allows you to do, after this topic, you have a set of exercises it could actually go. It could actually do, and that really boosts your confidence in solving those problems. But anyways, I think we should stop this video here, given it was a quick recap, and then we will do multiplication in the next video and the inverse of matrix. If we see that the multiplication of matrix really took more time than it's supposed to, we'll just jump into the inverse of matrix. Otherwise, we'll just do each in its own separate video. Okay, so thank you for tuning in and have a good day. See you in the next one.